call. All right, thank you. So after you select, no, this is wrong. Let me do this. File, new. Yeah, this is what you're gonna come across. So now let's say you wanna give it a name. First of Codesys. Maybe give it a date. I always like dates. They make life easy when you're sorting out your files. And then, so if you want to select a specific folder, you click there. Under documents, create a new folder, write it, maybe training code 1607-2022. Okay. Number one. Yeah, do you want to save? No, I don't want to save the changes. Yes. Right. Then the second step would be choosing the PLC now, which is this step. So we want to look for the control, Codesys control version 3. The Win stands for Windows. So Codesys control Windows version 3. Windows is the operating system of your computer, right? So now the language we are using is ladder logic. Then click OK. Then you're gonna come across this page. You as a new user of your PC, new user of the software, you need to come to Tools, Device Respiratory, and then you open Field Buses and you open PLCs. So under Field Bus, you will just go to the Ethernet adapter. Make sure that we are having 15 there. It's either 15.40 or 15 on the dot. And then you go to Modbus as well. Under TCP, the communication protocol we're using is a TCP. The TCP is more of Ethernet communication. So the other versions, you must uninstall them by clicking on uninstall. Then nah, it's fine because we've already covered it. Like your PC won't have that issue. Yeah. I'll tell you when to start following. What if I done? Oh, God, is equal to this activity. Can I just close here? So PLCs. Now we go to PLCs. PLCs, our PLC of interest, it's this one, Codesys Win version 3. Sometimes you'll find that there's version 16 here. There's a service pack 16.16. You must take out that service pack 16. You must take out that service pack 17, like you see here. So these guys, they also have for the 17, but we don't use this version 64. We only use this one. But it must not have other stuff embedded in it. You must uninstall them, those ones. And if it happens that you uninstall this one, I don't know how to reinstall it. You have to uninstall the whole Codesys and reinstall it. But in the lab here, you just restart the PC, it will come back. And then, yeah, because the computers are frozen. There are no more, you can't do permanent changes on my computers, basically. It's simple thing, language. So now, that's why you can follow now. You're gonna go to device, right click, then go to add device, and then you wanna select under Ethernet adapter, you're gonna select there, that Ethernet there. Select it and add it. Okay, if you want to, you can just close. Then you wanna go to that Ethernet adapter, right click, add device, and then you will find this thing like almost like this. Then you're gonna go under Field Buses, you're gonna go to Modbus, Modbus TCP slave device. Then you take that slave device there. Then you have this setup now. We have the Modbus that corresponds with the Modbus over here. So the inputs are managed here. Input, outputs are managed here. The unfortunate part is this connection only accepts digital signals. So in future, we're gonna do analog signal, but using OPC. I'm sure it's what you understand, whatever I said. It's a terminology, it's called mechatronics. It's what I did industrial engineering, so I don't know much about the theory behind these things. I just went. It's like driving a car.
No.
Yeah.
I have a mechanical background.
The clash. Yeah, the clash is, you can take 2 hours explaining it, but if we just put it on gear 1, it's okay, it will move. So that's what I do. So let's double click on PLC, and then you'll see that you will be able to get a page whereby you are able now to write code. This is where you write a code. When you click on here, then you'll see that stuff starts coming up. First thing first, I normally do now, I add the networks, the network line, so that I can have enough space to start writing, get it comfortable. Okay? And then we use variables, guys. We use variables. When on a small PLC, the basic PLCs, you don't use variables. You just drag I1, you write a code, I2, Q1, and stuff like that, but not here. Here we write variables, and the nature at which we are writing the variables is like this. You know that we have input 1 until whatever number, and output 1 until whatever number. It's going to be like this, I0. Then I0, oh, where do we write the variables? Okay, no. Only write the variables under variables. You see here, this says program. Then you go there on line number 2, you click enter. Then you'll have a space where you can write the variables. You don't delete the end variables, you don't delete the open variables there on top. Then you say I0 at. So now you need to follow the addresses now. The addresses are found under the Modbus. You can just double click the Modbus and you would go to IO devices, and you'll go to these ones here. So these are the addresses that we're going to use. I have seen people renaming everything here and it works perfectly fine. I don't like that approach. In PLCs, you use any approach you see fit, as long as it can work. So we want to do I0 at this address. So at percent I, okay, everything caps lock, please. I, and then X. Just in a while. IX 0.0, 0.0, right? And then colon, then bool. You know the boolean, bool, and then semicolon. Let me tell you something about this. In the space of programming, the semicolon, it stands for the code is done. Like you can just write it like this, it will be able to read it. Even your CNC, once you write that semicolon, it stands for the code is done. Then you do this, your forward slashes, then you're gonna say, this is my start button. My abbreviation for start button, I don't compromise, it's PB, start PB. That's my abbreviation. And then from here, one thing I can tell you is, if you want to rewrite this 100 times, I'm gonna have issues. You're not gonna do it. Trust me. I work with these things every day. You're not gonna do it. Copy that line, paste it. So we have a start and then we have a stop. Then just do it 3 times because we have 3 variables that we want to deal with. Then when you edit now, because now we have errors. Now when we edit, we're going to say I1. Then you come here. The address is 0.1. Now, it's our stop button. Stop button, PB. You can just say NC. NC stands for normally closed. Just in case you're dealing with a complex system, you can label it for yourself. All right? Then over here, we don't have any other input. So we can simply jump to output, Q0. Whenever you see the I, you remove it, you change it with a Q. And then over here, we have the conveyor belt, CV1, conveyor belt 1. So the controller conveyor belt. Yeah, conveyor belt. So your variables are fine. Now you start to write the code. So your variables can be as many as 100, depending on how powerful the PLC is. And then you write the code. And your variables must always correspond with the variables you are using here. They must always correspond. You don't compromise them. So, still doesn't want to cooperate. It's fine. So my start button, it's at I0 again. That's the first one. And the stop button, it's at I1. And then similar with your output, it's Q0.0. So why 0.0? Yeah. So why 0.0? We're gonna come back here. This is bit 0. Yeah. So the addresses, all of them, they're at 0.0. Then it changes. Normally, PLCs can cater up to 8 inputs, right? Even the Siemens PLC does that. It caters up to 8 inputs. So from 0, your 0 is more like 1, again, and then it goes until 7. Your 7 is more like 8. Then when you move to another bit, which is bit 2, it changes that to be bit 1. So it becomes address 1.0. So if it happens that you're programming a plant with a lot of inputs, you'll have to put 1.0, 1.2, 1.3, and stuff like that. Same with outputs as well. Same as outputs as well. We have a lot of outputs here. The detailed explanations, you watch one of those long, boring videos on YouTube, they will explain everything. Now I'm a user, I don't care. And I don't check out the opportunity. Okay, what am I doing? Oh, you click on it and then it will jump. Okay. It's more like of initializing. I've heard of that terminology called Arduino. Yeah, it's more like of initializing. Yes, it is initializing. So it kind of corresponds with whatever that you've done on the variables. You're gonna do. You are giving them meaning for it. You are labeling them. Or this one is going to be your I1, this one is going to be your I2, and stuff like that. Yeah, it's to initialize. So now we are Roman now. We want this one to be our I1. So if you click on it, you can just type it I0, enter. Then it will be able to recognize it as time goes on. Yeah, Papa, for now, it will, as soon as you start writing the code, it will do it. So normally I just rush and go to Q0. Again, so the code, the first line, the most critical first line of any program, this is the line. Then now we need to download the thing and see if we do have communication and stuff like that. So first thing first, you're going to go to System Tray, click on it, start your PLC, click OK. The PLC must change colors as time goes on. Yep, the PLC is illuminated now. It means that my PLC is on. The gateway tends to be running automatically. So what happens when these things are not here? Your system tray, it changes. Remember, it was dull. It was dull. It was gray in color. I know. So now it illuminates. Don't show this. It illuminates the color. Yeah. So they don't just come here by default, guys. Let's search for them. We are having Codesys. Apps. Should I say apps? Yeah, apps. You see the system tray. So you need to run the system tray. Then it will toma or system tray. So this is the system tray. Then you double click on the device, and we have a situation whereby it recognizes your computer that you are sitting on, and then you scan the network. When you scan the network, that PC must come up, and you click OK. Then this will turn on. I prefer using the one that is having your computer name. And then now it's active. So PLC, gateway, PLC. PC, gateway, PLC. When it's like this, you are allowed to download. In Codesys, the download log in, which doesn't make any sense. But just do it either way. Then you say yes. Okay? You know that you're doing something wrong when you don't get that orange color and 0 errors and 0 warnings. You are doing something wrong. It will tell you right away that something is wrong with your code. Okay, and then you're gonna go on top there, press start, and everything changes to be green. Even on Total, everything will change to be green. Right. So now here we are. We want to see. We connect. If it doesn't connect, something is wrong. It must connect. Click. Then come closer to the angle you want. Then you press start. Let go. It stops. Do you see that? This concept, people don't understand why we are looping, we're putting letting relays and stuff like that. So when you start PLC, this is the most important code of all. Because you press your start button, your machine moves, you let go, and it stops also because of our receiving loop effects or your use matching relays. So now you need to be able to make it to go until infinite, basically. So now, once it can start, you know what to know, indeed. So let's see now what happens when we are pressing the start button. On the code here, delete this, go up, and this can just, yeah, like that. So check this. I want ever blue. When I let go, ever white. So that effect must be always there. But this code doesn't go anywhere. And as much as it is important in my world of PLC, it leads nowhere. Then now we bring the loop. We come here, it's a parallel. So we make this to be parallel to there. And then you write Q0 there. So when this Q0 is on, this one will turn on, and it will help us to retain the signal. Yeah? Normally we put the stop button here. Let's not put it, let's download. and see what will happen. Right. Now we're back into business. Press your start. Look now. Start going. Until we press the stop. But we don't have the stop. We don't have the stop. All right. So let's bring the stop now into party. Let's bring the stop now into the party. Stop. The stop. Hey guys. Bye-bye. Listen here. I'm going to ask you a very funny question. Which stop button must I use? Either the negated one, which is a normally closed, or the normally open. Which one must I use? There's no right or wrong answer.
I think the normally open.
Why?
So that when you press it, it closes.
When you press it, closes.
Like, okay, it must be, oh my God, these terms are so confusing. It must be normally open. Okay. The stop button must always, the stop button must always, yeah, must always work.
Yeah. So explain, madam, last time.
I'm saying the stop button must always work unless you press it.
It must work, so it must connect, or it must disconnect.
It must connect unless it's engaged. So high duty mode, it must always be connected.
Yes.
So it's normally closed.
It's normally closed. So normally then closed, you put it as a normally open, so that when you press it, it can turn off. So this one is I1. Okay. I get it. It's a normally closed, and you could see even here where it's illuminating, or in a light current. So if you put it as normally closed, normally it will be. It means that it will light up. It will allow you to connect it. You understand? Because the normally closed switch as a physical switch, you connect it with the code that is normally closed. It means that it will turn off on that code. But if you connect it as normally closed, that code will see it, or indeed it's on, then it will allow us to run the program. You will see the moment we put a sensor. We are left with 10 minutes. This thing, I hate it sometimes. Going forward, I won't record because we've covered the basics that we needed. So I'll just, for maybe 10 to 15 minutes, I won't record. I'll just push the restart. Otherwise, we'll record forever. Because when we live in our time is almost up. When did we start? We'll finish. Let's push it cover. I'll charge you for 2 hours. Let's push until 1. It's fine. So you will see something. Okay, this one normally open. Immediately what's wrong with it now? I1. What's wrong with it? Wait. Oh, no, sorry. You must press that. Yeah. So if it was normally closed, it was going to be off here. But because of its normally, because it comes by default as a normal contact. So you must put it here as a normal contact, then it will let the power to pass through. The signal will be able to pass through. But if you cut it, the signal won't pass through. And they also act different between function block and with ladder. Because we have the softwares, it's up to you to test it until you understand it. You don't need the perfect definition if you can demonstrate it and say, okay, you know what, this means this to me, and it makes sense. Because these are the concepts that you're gonna use when you're running a real life machine in a plant. So you need to always be sure what you're doing. You don't hand over something to a company that it still confuses you. You need to clear all the doubts and stuff like that. So now I'm sure the conveyor belt, the product fell. Oh, it didn't fall. Oh, you need to press start. Okay, stop. Stop. Yeah. So the stop button works now. And it looks like this. Well, when it's blue, if you can negate it, it will never be blue. So meaning there won't be any current going in through inside it. It has to be blue, yes. Then when you press, as you can see, it moves. And when we are hard fall, we just press stop, it stops. Then and press, it moves. Okay. Also, are you able to download the software from your side?
I haven't done it.
Okay. Okay, but I have sent you the stuff. So
yeah,
now,
no, I got the email.
No problem. So now, as you can see, we don't have any input involved there that can stop this thing from falling. So Yawa and high stop will only depend on the stop button. Understand? So now, if we were to add a sensor, we would come here. The sensors are not the same, guys. There are sensors here that are normally closed and the sensors that are normally open. That's another thing I like about it. Before I confuse you, let me use a normally open sensor so that, because I know normally closed sensors are a bit complicated. All right, so this thing basically when it reaches here, this is a diffuser sensor. It comes as normally open. How do you see that your sensor is normally open? By just clicking on it, you will never see any funny colors. The moment you see funny colors, it doesn't correspond. Example will be this guy. This one normally it is normally closed. Today or play. Oh, Bivago now your sister to reflect you. Oh yeah. You see? So it's a neutral reflective. So it works out breaker the light. So anything that comes in between it cuts the signal. But we will get there when we get there. So now you don't just drop and leave things, you drop and program. I'm gonna put also an emergency stop button and explain why it's so important. Emergency stop button. I don't do alarms as yet, but you need to know what they are very important as well. I normally teach things relative to my reality. So for now, I still believe I must teach the switch, the switch there. But we're not okay. We're getting alarm when you are servicing people. Emergency stop button and your diffuser sensor one. And then there's nothing important this side. Right. So now we've added more inputs. Ne? Then you go to your configurations. You scopus, you need to have consistency. Inputs are outputs class. And you are allowed to say these are your station inputs. Station inputs. Can you see why you see that font is gray and it's green and in italics? It's because of these two things. If I remove them, it creates an error immediately. So they must be there. Whenever you want to comment, yeah, 100%. Station output, right? So, guys, I want to send you my tests at some point. the one that I use to test my own students. But obviously, as you progresses, I'll send you. Yeah, mechanical. Whenever I teach mechanical students, I'm not becoming your normal branic. I become,